Good morning, everybody, and today we're going to be looking at number 23 from the problem set in the lesson 1.3. So the question states, sketch a graph of the function f of x equals square root of x plus 2. Use your graph to determine each of the following. So as you can see here that I've already graphed f of x, which is the square root of x plus 2, and you can see that the function actually starts at -2 and then continues on. So let's get into the first question. The limit of f at x is the limit of f at x as x approaches -2 from the right. So as you can see from the right and approaching -2, which would be this point right here, you can actually see that f of x approaches 0. And that's due to the fact that the function continues to 0, but then the function does not continue after that. So the limit would be 0 for A. So B is asking the same question, but from the left. So what is so the limit of f at x as x approaches -2 from the left? As you can see from the left, the function actually does not exist. The function is not there, meaning that the limit also would not exist. So that means for the limit of f at x as x approaches -2 from the right, we have 0 as the limit. However, from the left, the limit just does not exist. So C, the limit of f at x as x approaches -2. So looking at A and B from the right and from the left, we can see that we have different answers. So we have A, the limit is 0, and B, there is no limit. It's D and E. This means that as x just approaches -2, the answer would also be D and E. This is due to the fact that whenever you have, or whenever the limit from the right and from the left do not match, the overall limit for that value that x approaches has to be D and E. For example, if they were both 0, then the limit as x approaches -2 would also be 0. But in this case, it's not. So for D, the limit of f at x as x approaches infinity. So infinity is going this way to the right because it's positive infinity on the x-axis. However, one can actually see that the function is infinitely increasing, meaning that the limit of f at x as x approaches infinity would also be infinity. So sorry, let me just copy that over. Now E, the limit of f at x as x approaches -infinity. So as you can see that the function actually stops at -2. So this actually means that the function would not or does not exist after -2, hence meaning that the limit as x of f at x as x approaches -infinity also does not exist. So this is just due to the fact that the function stops at -2 or x equals -2 and does not exist past that point, meaning that it can't approach -infinity, right? So there's no limit, hence the reason it does not exist. And that's it for today. So thank you, and I hope this solution to number 23 helps you a lot in this lesson.